All right, guys, let's go ahead and go through the following. You have been learning about chi-square, and today I'm going to focus on your notes from chi-squared, the GOF test, or our goodness of fit test. And I'm going to run through the two examples that were provided in your notes, because one is going to be represented and completed done historical data or the historical distribution, and the other one will be done using uniformed distribution. So let's go ahead, and again, we're going to use our notes, so you should hopefully have your recipe card with you in front, and I'm going to walk you through especially the important part, which is, of course, the calculator, knowing how to run the steps. So as always, we've got a stats professor. He reports historically grades in his introductory stats course has been distributed as the following. We are given some percentages for each grade. Grades in the most recent course were distributed as follows. Now, when you have a chi-square, this is a one variable because we're comparing the frequency of the grades and we're given a percentage. And if you were to take the time, you would see that the graph would actually be skewed right if you were to actually plot those data points. Now, what is going to be important here is that you always add up a grand total. So adding the frequency up of all those grades would provide us a total of 325. Now, when we look at our recipe card, we know that we need to go ahead and write our null hypothesis and alternative. So we've got the blank data follows a blank distribution. Well, we are talking about the stats grades. So the stat grades data follows and because there are percentages and it even says the word historically, we are going to say it follows a historical distribution. When it comes to the alternative hypothesis, the same thing. The stat grades does, and now we insert the word not follow a historical distribution. Do not change these out. They should be matching and be exactly the same. Now, as always, our step 2 is to go ahead and write out the equation. So we will follow x squared is equal to observed minus the expected squared. Again, notice that is in parentheses, divided by the expected values. Now, in step 3, it tells us to go ahead and calculate the expected values. If we take a look at this recipe card, again, we went ahead and said this was historical. So to figure out your expected values from historical, you're going to take the sum, the number of the observations in the sample. Hence why we went ahead and got the sum of these grades, which gave us a total of 325. Now, the next part says we're going to multiply the number of those observations by the historical percentage. So you're now going to say, okay, a total of 325. So I've got 325. Get over to my calculator here, 325. And now I'm going to go times. And for the A's is at 15%. So remember to convert it as a decimal, 15%. And now we're going to hit enter. And notice that gives me a total of 48.75. So our expected value of A's means we would expect in this class 48.75 would be the number of grades in this Intro to Stats course. You'll repeat the steps the same way for each of the other percentages, which is why you see now the list of these expected values. That then moves us on to step 4. You need to list them out. List out the expected values that you went ahead and got. Again, correlate, just list it out in step number 4. Step 5 says you need to enter the data into the calculator. We're going to put a check here. Notice though, when we do input it into the calculator, which we're about to do, we have to press stat. We're going to go edit. And now your frequency, your observed values will be the L1 column. Your expected values will always go into your L2 column. So I'm right now going to go ahead and input all of these values in. So we have 55. 109. Remember to always hit enter in the calculator. And now I'm going to move over to my L2 column, typing in those decimal points. 97.5, 130, 32.5, 16.25. Remember, your values should line up, directly correlate to one another. And then, as I always tell you in class, double check each of these. Take the few moments it might take for you to double check and compare the notes of what you have and the values you have now inputted into the calculator to make sure it is in fact the correct values. So let me double check myself. Again, I practice what I preach. Okay, and now I'm ready to go ahead and move on. So from here, we're now at step number 6. I ask you to go ahead and plug the values into the equation. Parentheses of this on your recipe card say to go ahead and do the first and the last expected value. Our first value is the A's. Our last value is the F's. Hence why you see 55 minus the 48.75 squared divided by 48.75. Now go to your F's, 12 minus the 16.25 squared divided by 16.25. We're now going to calculate the expected x squared value and our p value. So now we're going to go back to the calculator, stat, move over to tests. Notice I want an option D on your card. So we're now at option D for x squared GOF test. So that's one way to know what type of test are you actually running. So x squared GOF. So that is option D, as we see also on the card. I'm going to hit enter to go into that test. Noticed, observed, it says press second L1. This already says L1, so no change needed, and expected is press second L2. Again, no need. Should you have to change that, I'll go over that. That is a second, and then my L1 is right there above the 1 because it's blue and blue, and there's my L1. Second L2 would then be my expected. I now need to go ahead and input my degrees of freedom. Degrees of freedom is going to be your n value minus 1. So looking back at our notes, counting up how many frequencies of data do we have? 1, 2, 3, 4, 5. I'm now going to type in 5 minus 1. Whoops. Here we go, on the right screen now, 5 minus 1. Remember, let the calculator do this work for you. That's what we want. Again, if you don't change that, it's going to give you a different answer. And now I calculate, and we see, even on the notes, we see that our x squared value matches 5.2. I put 8 for 2 decimal places. You want to go to 5.277. Perfectly fine to do. Our p value, 3 decimal places, 0.2600. I rounded that, 0.260. Now in this particular problem, it does state I want a significance level of 0.05. So there's my 0.05 significance level. Remember, if you're not sure which way the inequality goes for our alpha, add on zeros to make it look alike. Well, drop now the decimal points on both of these and read them as if it was money. 260, so compare it to money, $260. Or would you prefer to have $50? In this case, I'd much prefer $260. So now I'm going to say that the p-value is greater. And anytime that the p-value is greater, as we see, p-value is greater than alpha, it is now a fail to reject. And so our last step will be to go down to our fail to reject conclusion, and we will be inserting that in. Our p-value is 0.260, and we've done enough conclusions of knowing how to fill in the blank, and it continues to follow to suggest that the stats grade does not follow the historical distribution. Now this last part, and this is probably the newest part that some of you have figured out or have not, what grade impacted your decision the most? Anytime you see that, that is called the CNTRB, which means the contribution. Now notice here on the calculator, I never left this screen, there is your CNTRB. If we look at the CNTRB, you'll see this data that follows, and you'll notice that the very first value, I want to like 2 decimal places, 2 or 3. I have 0.80, there's 0.80. I now see 1.35. I accidentally didn't round correctly, but if I start using my cursor to the right, I see there's my 1.35, there's the second value. There is my 0.27. Keep going, 1.73, keep advancing to the end, and we see that we're at the end. We have 1.1. From that, you will go ahead and pick out which one is the greatest value. 1.73 is the greatest. Who cares which one is different somewhere else? Just look at this string of numbers. Which one's the greatest value? Well, that is the first, second, third, fourth. I'm now going to go up to my table. First, second, third, fourth. That is the D's. So it is the D's that made the greatest impact on this. Now, to continue on with that, we say the D's made the greatest impact because the number of D's was something compared to the expected. Well, 25 is what than what we expected of 32.5. 25 is less than 32.5. Hence why you see it says less than expected. I hope you find that careful. In the next video, I'll go over question number 2.